Okay, this lesson is going to be on midpoint and distance. So the goal of this lesson is to find the distance between 2 points and find the midpoint between 2 points. So we're going to go ahead and start with two sets of points. We'll start with number 1 here. We have the point 1, 3 and 4, 7. So 1, 3 means it's a point from the origin. It's 1 to the right. It's 3 up. So 1 to the right, 3 up. That is going to be our first point. With our next point, that's going to be the point 4, 7, so that'll be 4 to the right and 7 up. Since they're both positive, the first number, our x value positive to the right, and our positive y value is up. So these are our points. I'm going to go ahead and connect them, and that's our line segment. So we want to find the middle point of this line segment, and we want to find out how long it is. So in order to do that, easiest way is to go ahead and from the highest point drop a vertical until it's even with the lowest point, and we'll go ahead and put over a horizontal, and what we've done is made a right triangle. Let's go ahead and count how long each side is. This is 1, 2, 3 units, so we'll put a 3 here. This will be 1, 2, 3, 4 units. We'll put a 4 there. So we know how long each side is. Now to find the midpoint, there's 2 ways to do this. You could go, well, there's more than 2 ways, but 2 ways I'm going to show you is go to each side and find the middle of each side. So if this is 3 units long, then 1.5 would be the midpoint of the side. And then go straight up till you hit the line. Or you could go to the middle of this side. If it's 4 units long, you can go to the middle, which is 2 units up or 2 units down. You can draw over, and you can see it hits the same point. This location is the midpoint. And so we can see it is 1, 2, 2.5 to the right. So we'll put 2.5, 2.5. And we can see that it is 1, 2, 3, 4, 5 units up. So this location is 2.5, 5. Now you could do that another way. I'm going to give you the midpoint formula. Midpoint, which is you take the x values and you combine them together and divide by 2. Essentially you're taking the average of the x values, and that will give you the x value of the midpoint, and then you take the average of the y values. So you add the 2 or combine the 2 y values together, divide by 2. So the reason I have x and this number down here is, we say sub 1, x sub 1, and this is x sub 2. X sub 1 is the x value of the first point, and x sub 2 is the x value of the second point. Then y sub 1 is the y value of the first point, and y sub 2 is the y value of the second point. So to solve this, I would take x sub 1, which is 1, plus x sub 2, which is 4, and divide it by 2. 1 plus 4 is 5, and 5 divided by 2 is 2.5. So that's how we got the x value. For the y value, we're going to take the y sub 1, which is 3, and we're going to add the y sub 2, which is 7, divided by 2. So that's what we're following this equation here. 3 plus 7 is 10. 10 divided by 2 is 5. So it's the same answer we got, but we did it algebraically, or numerically. No, we'll call it algebraically. Where this one we did it graphically. Now, what about the midpoints for these 2 points? Well, let's go ahead and graph where these are. Now, this x value is negative, which means this is going to go left, and this y value is negative, so that's going to go down. This is also left, so because it's negative, and then this one will go up because it's positive. So remember, a positive x goes to the right, negative goes to the left. Remember, this is your x-axis, this is your y-axis. Positive y goes up, negative y goes down. So negative 5, negative 1 is this location right here. And negative 2, positive 1 is this location right here. So that's these 2 points. I'm going to go ahead and connect the dots. And then we're going to do the same thing. We're going to drop a vertical from the highest point till it's even with the other one and draw a line over. This is 2 units long. This one here is 3 units long. Half of 2 is 1, so that would draw a line straight over. half of 3 is 1.5. 1.5. So draw that line. We get this nice point there. Now what is the location of that point? That is 1, 2, 3 and a half to the left, so negative 3.5. And well, it's not going up or down, right? It's exactly on the x-axis. It didn't go up, it didn't go down, it stayed even with the 0, so that is a 0. Now we can confirm this answer by doing the same process here that we did over here. So our x sub 1 is negative 5. Our x sub 2 is negative 2. I'm going to put a parenthesis around it since it does have a plus and then a minus right after it. Divided by 2. And to get the y value of the midpoint, we're going to take negative 1 plus 1 divided by 2. And then we'll just do the math here. So negative 5 and negative 2, this is an alliance, right? They're both negative values, so they'll combine together to make an even more negative value, right? Because the negative army just got bigger, right? It had 5, now it has 2 more, so the total is 7. And negative 7 divided by 2 is a negative 3.5, which we knew. Here, negative 1 plus 1, that's what we call a zero pair. They're opposites, and so it would give you 0 over 2, which is 0. Alright, the next part of the lesson, I'm not going to take time to read this to you. Basically it just talks about the Pythagoreans and the Pythagorean theorem, which is this theorem here. We're going to go ahead and flip it. And there's some more information about them. But what Pythagoras and his group came up with is if you have a right triangle, that the two legs we'll call A and B, and then the length of the longest side opposite the right angle, that's hypotenuse, that would be C. So if you have a right triangle, then the legs squared and then added together should equal to the length of this side squared. So a great way to look at this, and here I did what we call a 3, 4, 5 triangle, and so I'll just kind of sketch that out for you right here. So if we have this length of 3, so we'll go 1, 2, let's try to make it as even to 3 as we can. To try and keep it consistent, I'm going to go ahead and try and measure this a little bit. So I'm going to use 3, I don't know if I have enough room to do what I want to do here. I'm going to go ahead and draw this 3 units this way. And then I'm going to try and go 4 units straight up. So I'm going to put a 4 there, and I'm going to try and go straight up with it. That brings me a little bit high there. And if I did a good job making this a right angle, this distance here should be 5. And it is. So yeah, I did a pretty good job. There we go. And so that's what we wind up at. This is a 3, this is a 4, and this is a 5. Now how does this work? Like mathematically, well 3 squared is 9, and 4 times 4, 4 squared is 16, and 5 squared is 5 times 5, which is 25. And 9 plus 16 is 25. Here's a way to look at it. So I went ahead and drew a triangle here, a 3 length here, a 4 length here, and then we're going to talk about this being a 5 length. When the Pythagoreans or the Greeks looked at these type of things, when they said something was squared, they literally saw it as a square. So I'm going to go ahead and draw a square off of this side, making this a 3 by 3 square. Right? This length side is 3, and so by making this side one of the sides, this is the other side, same length, so we've created a square. How many squares do we have in here? So we have 9 squares, right? Or 3 times 3. If I do the same thing here, I'll come over 4 units. now we've made a 4 by 4 square, and so if we kind of number these 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We can see that that has 16 squares. Now, these 9 squares plus these 16 squares, if you add them together, is a total of 25. Now, what I've done here is I have a square that's a 5 by 5 square. I'm going to set it right here. You can see that it lines up perfectly with this other side, and it has an area of 25, the same as these two areas added up together. And so this is what the Pythagoreans realized, and they saw this visually. This is how they said, hey, if we have this side and we make a square off of it, and make a square off of it here, the number of squares here is the same as the number of squares you're going to get on this side. And so that's how they kind of came up with the Pythagorean theorem. So we need to remember, when we go through and square these two sides, the answer we get here is going to be the number of squares that is formed when you make a square off this other side. So let's go ahead and do this. This is the same 2 points that we did last time. So we're going to do the point 1, 3, which is here. We're going to do the point 4, 7, which is here. We're going to draw them. We're going to connect them. And in this case, this side is 3, this side is 4, and this side, that makes this side 5. It's the same math that we saw up here. And it's nice when these work out nice and neat like that, where you get a 3 and then a 4 and a 5. This is a pretty common one. But not all of them work out that way. Let's go and do the next one. -5, -1's down here, and -2 positive 1's, this one's the one we did before. And now we'll draw these horizontal and vertical lines just like we did before. This is still 2, this is still 3. So the question is, how long is this side? Now I can use that paper that I had to at least kind of count out how long we think it's going to be. So that's like 1, 2, not quite 3, right? These 3, and if I start from here, 1, 2, it doesn't quite make it all the way to the third square, does it? So it looks like it's going to be 2 point something. So this doesn't work out as nice as this one, where you don't get a nice, neat answer from it. And so I can kind of take a look at these, right? If I take a look at this square and make another 3 by 3 here, I can see that this is going to have 9 squares. This is going to have 4 squares. And I'm going to do that math over here. So I'm going to say 2 squared plus 3 squared equals this side squared. There is going to be some sort of square here, right, where the sum of these two is going to equal this one. So let's do this. We said that's 4, that's 9, add that together, that's 13. So this is the problem we have, is 13, I can't multiply a number by itself and get 13. I can take, if I do 3 times 3, that's 9. If I did 4 times 4, that's 16. 13's in between there. So it's not going to be an exact value. So this is where we're going to pull out our calculator. So I'm going to pull my calculator out here. And with your calculator, you're going to have a button. If I can refocus this a little bit. Yeah, this squared button right above it, you have this square root. This is the opposite operation of squaring. So in other words, if I need to find out what number multiplied to itself is 13, this is going to do it for me. So I would go second, and then I would hit the x squared to give me the square root, and then I'd put a 13 in the box. Now what that's going to do is it's going to tell me how long would the sides have to be for you to get 13 squares in this image here, right? So if I multiply it, I got to change the mode, sorry. Classic. We'll quit out of that. Square root of 13, and we'll hit enter. So it's about 3.6. So we knew it was between 3 and 4, and when we, okay, Yeah, so between 3 and 4, so because 3 squared is 9 and 4 squared is 16, so it has to be somewhere in between here. So with that, we were going to write our answer, so we'll say c squared equals 13, so c equals the square root of 13. So we'll write c, and we'll put these squigglies here to say this is not going to be an exact answer. This is going to be a rounded value. So about 3.6, and that would be the length of that side. Alright, I feel kind of foolish. I was using this and like trying to measure it with, these are different grids. Oh, sorry. These are totally different grids. I was like, well, why isn't this matching my answer here? Because I'd used this earlier to count it, right? But this piece of paper, this graph paper, doesn't match this graph paper. These are much bigger squares. I should have used one similar to this size, which I don't have handy. So I apologize for that miscommunication on that. That doesn't work. If I were to draw that on a regular sheet of graph paper, something like this, now I have my 2 and my 3. Now this will work for me, right? So if I put it here, we can see 1, 2, 3, and then we have a little bit more, right? And so we're saying about 3.6. Well, there's 3, there's a half, it's a little bit more, so 3.6 looks pretty reasonable, right? 1, 2, 3, and then a little bit more. So that does match up if I use the same size grid. All right, so that concludes this lesson.